Hello everyone, this is Dr. G. Karthik Reddy working as Associate Professor in the Department of EC, MLR Institute of Technology, Hyderabad. Today's session topic is jointly wide sense stationary random process. Okay, in this session we are going to discuss concept on jointly wide sense stationary and the problem related to jointly wide sense stationary random process. Okay, what is the definition of jointly wide sense stationary process? Okay, jointly, if x of t and y of t are two random process, if x of t and y of t are two random process, then if it has to satisfy the jointly wide sense stationary process, it has to satisfy three conditions. That is, expectation of x of t must be constant. Next, second condition, expectation of y of t must be constant. Next, third condition, cross correlation must be function of tau. Okay, these are the three conditions it must be satisfied for jointly wide sense stationary process. Now we will discuss the problem related to this concept. Okay, you read out here two random process are defined, x of t equal to a cos omega t plus theta and y of t equal to b sin omega t plus theta, where theta is uniform random variable defined over the interval 0, 2 pi. Here a, b and omega are constants. Find cross correlation function and verify whether x of t and y of t are jointly wide sense stationary or not. Okay, here you can observe clearly that here first, whenever they given the question, first observe which one is a random variable. Here theta is a random variable. Okay, here given data, first you have to define theta is a random variable defined over the interval 0, 2 pi, and they are calling that as theta is what type of random variable? Uniform random variable. Uniform random variable, you know the condition that f of theta. Okay, here they are considering theta is a random variable, means theta is a random variable, f of theta is a density function. It is defined only for the interval theta of the interval 0, 2 pi. 0, 2 pi interval it is defined. Then if it is f of theta becomes what? F of theta becomes what? 1 by b minus a, that is 1 by 2 pi, and it is defined for the interval 0 less than or equal to theta less than or equal to 2 pi and 0 otherwise. Means it is defined only for the interval 0 to 2 pi. The value of density function is 1 by 2 pi. Okay, what we can conclude that, okay, you can write this side, f of theta is equal to 1 by 2 pi for the interval 0 less than or equal to theta less than or equal to 2 pi. Now get back. Now next here a, b and omega are constants. They are given in the question that a, b and omega are constants. Now first we have to calculate. Okay, for they are asking that two questions, cross correlation function we have to calculate and verify whether x of t and y of t are jointly wide sense stationary or not. Okay, you can in the same second question only we will get the cross correlation function also. First, what is the condition of jointly wide sense stationary? Jointly wide sense stationary, just now we have discussed, expectation of x of t must be constant, expectation of y of t must be constant, and cross correlation function must be function of tau. Okay, these conditions it must be satisfied. First we will calculate expectation of x of t. Okay, which is a formula you are having integral minus infinity to infinity. Here whatever you are having x of t. Okay, here next you are having fx of x comma t dx. Okay, now here what you are having, interval it is defined 0 to 2 pi. Interval it is defined 0 to 2 pi. Then what you are having, you write the x of t is equal to a cos omega t plus theta. Here the interval is 1 by, what is the condition, f of theta. Here f of theta into d theta. Okay, f of theta into d theta you have to represent because here theta is defined. Okay, f of theta into d theta. Then what you are going to get, a is constant, take outside. Here f of theta is defined by 1 by 2 pi. 1 by 2 pi is f of. Then a by 2 pi you can take outside. A by 2 pi integral 0 to 2 pi cos omega t plus theta into f of d theta. Again I will rewrite this one. Okay, a by 2 pi 0 to 2 pi cos omega 1 plus theta d theta. Okay, now we have to simplify this one. Then what you are going to get, a by 2 pi cos integration is sine omega t plus theta. Okay, and next we substitute the interval 0 to 2 pi. Then a by 2 pi, and what you are going to get, sine omega t plus 2 pi minus sine omega t. Okay, the sine term will repeat for every 2 pi cycle. Then the sine omega t plus 2 pi is sine omega t itself. Then these two terms will get cancelled, will get 0. Means expectation of x of t is 0, which is constant. Now we will calculate expectation of y of t. We have to prove that expectation of y of t is also constant. Okay, here it is also same formula, integration minus infinity to infinity b sine omega t plus theta into f of theta d theta. Here again the f theta is a uniform random variable. Then it is defined as f of theta is equal to 1 by 2 pi for the interval 0 less than or equal to theta less than or equal to 2 pi. Then change the interval 0 to 2 pi b sine omega t plus theta 1 by 2 pi into d theta. Now again simplify it, you will get p by 2 pi is a common term. Then sine, what is that, integration you will get minus. Okay, minus of cos omega t plus theta. Here you change the interval 0 to 2 pi. Okay, then what you are going to get, minus b by 2 pi cos omega t plus 2 pi minus cos omega t. Okay, here cos or sine both are repeating every 2 pi cycle. Okay, then here also resultant as 0 itself. Then expectation of y of t is equal to 0, which is constant. Now next last condition, that is cross correlation function must be function of tau. You know the formula that rxy of tau is equal to expectation of x of t y of t plus tau. Now substitute it, expectation, what you are going to get, expectation of a cos omega t plus theta, next b sine omega t plus tau plus theta. Now you can take here only the AB is constants. Okay, you take AB as constant common, expectation of cos omega t plus theta sine omega t plus omega tau plus theta. Okay, now we can't simplify this one, multiply and divided by 2. Then you are going to get in the form of 2 cos A sin B form. Okay, then you are going to get the formula. Okay, what is the formula, what here you are having, 2 cos of A minus B. Okay, then we are having the sign of, you substitute that formula. Then you have to simplify that, integration minus infinity to infinity, integration minus infinity infinity. Here whatever you are having, you substitute that. Okay, 2 cos A cos B. Okay, 2 cos of omega t plus theta, here sin omega t plus tau plus theta. Then again you are going to get, okay, here 2 cos A sin B form. Okay, here you simplify it further. When you are going to get a square by 2 sine omega tau. A square by 2 sine omega tau. Okay, then you are going to get, this is the, if you simplify it further, you will get a square by 2 sine omega tau. Here rxy of tau. Okay, rxy of tau. This is also function of tau. Cross correlation function is also function of tau. Then the given, it is satisfying jointly, White's and stationary.